Problem 530, minimum absolute difference in BST. So here we're given the root of binary search tree, and we need to return the absolute difference between the values of any two different nodes in the tree. So that means we need to get the difference between 1 and 2, and 1 and 3, 1 and 4, and 1 and 6, get the minimum difference and update it. But it's not really ideal because there's just too much computation going on. And logically, it doesn't really make sense to compare 1 with 4 and 6 when we could have just compared with the next smallest number, which is 2. Likewise, when we're looking at 2, we should compare with the next smallest number, which is 3, and then 3 should also compare with the next smallest number. Because if you compare with any larger number, the difference is obviously going to be bigger. So what we want to do is we want to ideally put them in order of the size and compare 1 and 2 and update our value, and then 2 and 3 update our value, and then 4 and 3 and 4 and so on. So how can we do this? Actually, one of the properties of BST is as we go from left to right, the values of nodes increase. And to achieve that, we have to carry out in-order traversal. So we've done a couple of in-order traversal before, and to do that, we have to use DFS. So that means there should be some function, DFS, that will recursively get the nodes in the tree from left to right. So it will take in tree node of node, and our initial goal is to write down the function that can reach the bottom left of the node. So to do that, we just need to recursively call node.left. And then it would be DFS root. And we ideally need to have some private int answer, which will store the minimum difference. So it will be integer.max value. And at the end of this function, we just return answer. All right. So if we do DFS node.left, we will reach this node 1. But when we get to the next left, which is null, we need to stop it. So we do need some if statement. If node is equal to null, we just simply return, which means we end the recursion. So we are at 1 now. So we are at 1, and then since we don't have anything, it's gonna go back to this node 2. But when we go back to node 2, we should have stored the value of node 1. So we do need some statement that can hold the value. So we can say, what should we say? So we can say previous is equal to node.val. So that would be private int, let's call it integer. There's a reason for it. Initially, it's going to be null. So we recursively got to 1, and then we update our previous to node val. And then we got to node 2, and then we override this with node.val, which is what we want to do. We want to compare. We want to do some comparison. So we are going to compare and then update our previous variable. So how should we do it? If previous is not equal to null. So that means when we are at 1, we just update our previous variable because it's essentially null in the beginning. If not, we do update our answer. Answer is equal to math.min ends, and then node.val minus previous. So what we've done is, so we recursively got to 1 and then update our previous value with 1, and then we got out of the recursion back to node 2, and we've seen that previous is not null, so we get the value of this and then previous value, find the difference, and then whichever is smaller, this and this, we up that becomes our new minimum value. And then we need to go to the right of the node, so it should be in order. It should be DFS and node dot right. So this way we are recursively getting all the nodes from left to right and then updating our answer. Okay, let's run the test. Okay, let's submit. All right, that's it.